Hi, this is Mrs. Sigala, and this is your review for your test on safety equipment and measurements. First three problems on our on our test review are in regards to safety rules, location of safety equipment, and also being able to recognize basic lab equipment. Number 4, measurement techniques. Use a delphal digit and unit in recording scientific measurements for the following. So for A, we have a ruler and we have an arrow right on the 1. So in this case, my answer would be 1. Okay. I could put 1.0. And in this case, my 0 would be my doubtful digit. All right, then I go over to B. And I see a graduated cylinder. And let's assume that this one is in, it doesn't matter whether it's liters or milliliters. All we have to know is we have to look at the major scale. We know that between 80 and 90 is 10 milliliters or 10 liters. So that means that for our minor scale, that has a value of 1. So we start at 80, 81, 2, 3, 4, 5, 6, 7. So for sure we have 87. We know that for a fact. But then we see our meniscus, and it's like maybe about halfway between 87 and 88. So in this case, we can add the 0.5, or the 0.5. And this 0.5, that would be our doubtful digit. C, we end up with 6, and we can safely assume that maybe 5 is right in the middle. But in this case, it's a little short of the middle, so I'm going to go ahead and go with 6.4. And that 0.4 would be my doubtful digit. Next, I go to D. And I know for sure I have 3, and between 3 and 4, here's 0.5. And every minor scale in this case is worth 0.1. So from here we go 3, 0.1, 0.2. So we know for sure we hit 3.2. But that is between 0.2 and 0.3. So in this case we can write 3.25, and this 5 would be my doubtful digit. Alright, so then number 5, what are the metric base unit symbols for length? In this case, the basic would be meter. For mass, it would be gram. For volume, it would be liter. And for time, it would be seconds. Okay. So what is the prefix for kilo, or the unit for kilo? That would be a K. For centi, would be a C. For milli, it would be an MM. Right, what does kilo mean relative to base units? Well, we know that we have 1,000 basic units in a kilo, so a kilo is actually 1,000 times larger than our basic unit. Okay, what is the prefix for centi? Well, what does centi mean relative to the basic units? Centi is a piece of our basic unit. So in this case, centi actually means 100 times smaller than our basic unit. Okay. And milli is tiny because it is 1,000 times smaller than our basic units. Alright, so let's look at the next section in regards to significant figures. And remember, with your hands, P stands for present. You'll be going from left to right. If the decimal point is absent, okay, you can make this with your right hand. You'll be going from right to left, first non-zero number. All right, so for A, we see that there is a decimal point present. Our first non-zero number, okay, so we start counting with 8, and then we count all the numbers after that. So in this case, we have 3 significant figures. For B, we do have a decimal point present. Our first non-zero number is 2, so we count that. 2.34, that's 3. C, well, we have our decimal point is absent, so in this case we go from right to left. Our first non-zero number is 3, so we only have 1 significant figure. D, our decimal point is present, so we go from left to right, and in this case we have 5 significant figures. E, our decimal point is present, so we go from left to right, and our 3, 1, 2, 3, 4, and we have 5 significant figures. again, we have our decimal point present. So we go from left to right. And our first non-zero number is 6, so we don't count these zeros. We do count everything after that, so we end up with 4 significant figures. G, our decimal point is present, so we go from left to right. We have 4 significant figures. H, we do have a decimal point present. Again, left to right, and we have 6 significant figures present. Alright, so complete these problems using correct significant figures in your answer. You'll definitely need your calculator for this one. Don't bother doing this by hand. Alright, so this one I entered into my calculator, and my answer was 0.075332. And then because I multiplied meter times meter, that's going to give me meter squared. Oops, sorry. Alright, so now let's look at our significant figures. We do have a decimal point present, okay, and when we're multiplying, we go with the least number of significant figures. So what I always do is I always write it right above. Here I have 4 significant figures, and here I have 3 significant figures. This means that my answer must have only 3 significant figures. So again, the decimal point is present, so I'm going from left to right, and that means that first non-zero number, so I start counting my significant figures until this 3. Okay, so the 3, the first will be my doubtful digit. This 3 does not affect this 3, so my answer would be 0.0753 meters squared. Okay, I look at B, and again, I'm going to look at, I'm multiplying. So I'm going to look at the least number of sig figs. So I look at 302,000. The decimal point is absent, so here I have 3 sig figs. Then here I have 2 sig figs, so my answer better have 2 significant figures. So let's do the math. And in this case, it comes out to, let's see. So we have 302,000 times 3.5. We end up with 1,557,000. Sorry, this is a big number. So we end up with 1,057,123. Okay, and again, millimeter times millimeter is millimeter squared. But now I have to fix my significant figures. Okay, and so I want 2 significant figures. So I look at my first 2 digits. My 0 is my doubtful digit. I look to see what this 5 does to the 0. Makes it a 1. But again, 1,057,000 is not the same as 11. So I need to, it's almost like rounding. So I'm going to keep adding my zeros. So my answer is 1,100,000 millimeter squared. If you wrote this in scientific notation, that's okay too. Okay, my next problem, I'm dividing. So again, I'm going to be going with the least number of sig figs. So here I have 2, here I have 3, so my answer better have 2 sig figs. So I'm going to input this into my calculator, 8.13, and then e to the 4th. And I'm going to divide by 3.8 e to the 2nd. And my answer is 213. Okay, so 213.95. Okay, so let's see. 213.947. I won't leave it there. Okay, and again, when I'm dividing meter squared by meter, it only cancels out 1 meter, so my unit that's left is just 1m, not meter squared. Alright, so then I need 2 significant figures, so again, I look at my first 2 digits. Here they are, the 2 and the 1. How does this 3 affect this 1? It doesn't, and so my answer would be 210 meters. Next problem, I have 27.54 seconds minus 3.8 seconds. Now we're subtracting, okay? And remember, when we're subtracting, we go with our least precise equipment. In this case, since this 3.8 only extends out to the 10th place, we know that that is less precise than going out to the 100th place. So my answer better not extend more than the 10th place, okay? And so be careful with the rules. They're not the same as multiplication. So I take 27.54 minus 3.8, and my answer is 23.74 seconds. Okay, but again, my answer cannot extend beyond the 10th place, so I need to just leave it at the 10th. Does this 4 affect the 7? It doesn't. So my answer is 23.7 seconds. All right, E. Again, 4.6 E. Okay, so E to the 5th plus, so I'm adding. So again, I have to be careful, and I need to look at my equipment, see which is least precise. Plus 3.2 E to the 5th power. Oops, made a mistake. 4.6 E to the 5th plus 3.2 E to the 5th. And that's going to give me 780,000. Okay. And so in this case, you can also leave it in scientific notation if you prefer. So it would be 7.8. It can either be 7.8 times 10 to the 5th power. Okay, sorry, I should have written that in purple. Okay, because those exponents are exactly the same, so all you're doing is adding. Okay, all right, F, we go to 765 plus 37.2. And again, because of this whole number right here, okay, that means that our equipment isn't very precise, so we cannot extend it out to the 10th place. So in this case, 765 plus 37.2 would give us 802.2 grams. But again, we cannot extend out to the 10th place because our equipment isn't accurate, so my answer would be 802 grams. Okay. Now we go to G. So we got 3.2, and here we're dividing. So again, we're going to go with the least number of sig figs, which is 2. So 3.2 divided by 3.563 gives me 0.89811. And I can stop here. The meters doesn't cancel out the seconds, so I end up with meters per second. But again, I only want 2 significant figures, okay? And so I'm going to look at my first 2 digits right here. Well, 9 would be my doubtful digit. This 8 changes that. And so in this case, my answer would be 0.90 meters per second. All right, so then we go to number 11. It asks us for to define accuracy. And remember, in order for us to define accuracy, we have to have a known, or we have to have a true value. I can't, like I told my students, I can't jump on a scale and say it's way off if I don't know what my weight is to begin with. So for accuracy, our definition would be how close a measurement is to a known. Another word for known, it can be true or a true value. Okay. All right, for precision, we have to have 2 things. So in precision, if you don't have one or the other, then your equipment is not precise, or we're not precise. So in this case, 2 things matter. So the more significant figures that we have, the more precision, and again, repeatability. So both the number of sig figs and the repeatability of a measurement, which is why we do multiple trials in an experiment. Repeatability of a measurement. So then we go to number 12. Mike and Steve each have measured the length of the same object 3 times using different rulers. Okay, and so the true or actual length of the object is 19.98. So this would be our known value, 19.98. Where these or whose measurements are more accurate? So let's see who's closer to our known. So in this case, we look at Mike, and he's pretty close, and Steve is off by about 3 to 4 centimeters. So in this case, Mike's data. Okay, so Mike is more accurate. Okay, whose measurements are precise but not accurate? In this case, Steve. His measurements also extend out to the hundredth, so the number of sig figs is the same, and again we have repeatability. So in this case, Steve, he didn't hit the target, but he did have the right number of sig figs and repeatability. Alright, so next we go to scientific notation. Okay. Alright, so it's asked to convert the following to and from scientific notation. We look at our very first number. And again, so here our decimal point, our number overall is less than 1, so we know for sure our exponent is going to be negative. Now we look to see how many times you have to move our decimal points in order for this number to be a number between 1 and 10. Okay, so in this case, if we were to make this a number between 1 and 10, we could put the decimal point right there, but we'd have to move it 1, 2, 3, 4, 5, 6 times. Okay, and so in this case, our number would be 5.0830 times 10 to the negative 6th power. I look at B, and again, I need this number to be between 1 and 10, so what I could do is I can actually put the decimal point there. But in this case, 1, 2, 3, 4, 5, I move my decimal point 5 places. And because 308,000 is greater than 10, in this case, my exponent will be plus 5, and so my number is going to be 3.08 times 10 to the 5th power. And my unit is going to be seconds. 1, 2, 3, 4, 5. Okay. All right, my next number is C. Again, I would want my decimal point there because I want this number to be between 1 and 10. 1, 2, 3. So it would be plus 3. So it would be 7.004 times 10 to the 3rd power. And my unit would be meters. Next problem. In this case, now going from scientific notation to regular, or to, what is it called? Conventional notation. So in this case, I see that my exponent's positive, which means I'm going to be moving my decimal point to the right. And in this case, I'm moving it 4 places. So I'm going to 1, 2, 3, and then 4. Here out at a 0. So my number would be 26,510 meters. Okay. E. Again, my exponent's negative, so that means I'm going to be moving my decimal point over to my left. So 3 times. 1, 2, 3. Here goes my decimal point. So my number in this case would be 0.00810 kilometers. F, 1.1 times 10 to the 5th milligrams. It's positive. I'm going to be moving it to the right 5 places. So, you know the space, kind of write it down. 1, 2, 3, 4, 5. And here I'm going to add zeros. So here my number would be 110,000 milligrams. Alright, complete the following math problems. You need your calculators, and you have to know how to use a calculator. Don't forget about using your E. You don't have to multiply times 10 and then put in your exponent. So 2.92 times 10e negative 5th times 4.78 e to the negative 12, and I end up with 1.39576, okay? But again, don't forget significant figures. We're not going to remind you each time. So let me put this in red. So this is the answer given to me by my calculator. So if you got this answer in your calculator, you're good so far. But now I need to have the right number of significant figures. So again, here we have 3 and 3. I'm multiplying, so I'm going to go with the least, so I need only 3 significant figures. So look at my number. These are my 3. This 5 does affect this 9, and so my answer is going to be 1.40 times 10 to negative 15, and my unit is going to be kilograms. All right, next one, we have 5.23 e to the 17th power times 1.2 e to the 21st power. Again, I'm multiplying, so I'm going to go with 2 sig figs because that's the least amount. And my answer on my calculator is 6.276 e to the 38th power. But again, only 2 significant figures, so I want to look at this and I'm going to say these are my important ones. This 7 affects my doubtful digit, and it makes it 6.3 times 10 to the 38th power, and my unit is, oh, there's no unit. All right, last problem. In this section, we have 7.3 e to the 5th. Again, we're multiplying times 4.59 e to the negative 9. And again, oops, sorry. Here I have 2 significant figures. Here I have 3, so my answer better have 2. So I'm going to write down what my calculator says just so you can confirm that you're getting the same thing as I am. So 0.0033507. But again, we only want to keep it at 2 significant figures. So you're welcome to write this in scientific notation. And if we were to do that, again, these are my first 2. This 5 affects this 3, making it a 4. So you could write it down as either 0.0034 or as 3.4 times 10. And in this case, we would have moved it 1, 2, 3 places. So it negative 3. Okay, so in this section, I'm going to be using dimensional analysis. Okay, remember, always write your given first, then allow for your units to guide you. So first one is asking me to convert 25 millimeters to meters. Okay, so again, I'm going to write my given 25 millimeters. And I'm going from a prefix, milli, to my basic unit. So in this case, that means I'm only going to have a one-step problem. Since I want to get rid of millimeters, I know it's going to go in my denominator and meters on the numerator. So I know that 1 meter is equal to 1,000 millimeters. Again, my millimeters cancel out. And once I'm happy with my unit, which I am right here, I can write my equal sign. So this, you can either write it down as 25 meters over 1,000, and then do the math, which would be 0.025. Or if you want to write it down in scientific notation, it could also be 2.5 times 10 to the negative 2nd power and meters. All right, next one's asking me to convert 1,234, so again, my given, meters, which is my basic units, and I want to end up with centimeters. So this is also a 2-step problem. I want to get rid of meters to centimeters, okay? And I know that there is a direct link between the two because my basic unit to a prefix. 1 meter is equal to 100 centimeters. Again, my meters cancel out, and I end up with, 1,234 times 100. Okay, 123,000 meters. Or you can also write it down as 1.234 times 10 to the 5th power centimeters. Oops, sorry, I wrote the wrong unit over here. That should be centimeters. Okay, so now, C, I'm converting from kilometers to millimeters. So in this case, I'm going from prefix to prefix. So this is a 3-step problem because the easiest way for you to solve this is to always go back to your basic unit. So here, 2.3 kilometers, my given. I know that, I don't know how many millimeters in a kilometer, but what I do know is that 1 kilometer is equal to 1,000 meters. Right here, I can cancel out my kilometers. I'm not happy with meters yet, so I need to get rid of meters. Okay, so here, I know that 1 meter is equal to 1,000 millimeters. So now I can write my equal sign because that's what I want to get to. I want to get to millimeters. My meters cancel out, and now I just have to multiply 2.3 times 1,000 times 1,000, and that's going to give me 2.3 times 10 to the 6th millimeters. Okay. All right. Next one is asks us to convert 4.7 grams of hydrogen to liters. Okay, and they give us the information. So in this case, we know that 1 mole is equal to 2.06 grams of hydrogen, and 1 mole is equal to 22.4 liters. So again, let's start with our given. Don't get intimidated if you don't know what the terminology is. So let's start off with 4.7 grams. Okay, so let's look at what or how we can get rid of grams. We know we want to get rid of grams. Okay, so here's grams right here. So we can go from mole to liters. So 2.016 is equal to 1 mole. Now we can get rid of our grams, but we don't want moles, we want liters. So we have to continue. So now we're going to multiply. We want to get rid of moles. So according to our equality given to us, 1 mole is equal to 22.4 liters. I'm happy with liters, so now I can write my equal sign. My moles cancel out. And again, I'm going to multiply my numerators. So my numerator is, and I always like to set it up, even if it takes a little bit longer, 4.7 times 22.4 times 1. In this case, my answer is 105.28. And remember, don't forget your significant figures, okay? And again, liters. And now let's look at my denominator. Well, I have 2.016 times 1, so my denominator is 2.016. So now I divide my 105.28 by 2.016 and end up with 52 with the repeating 2. Okay, so liters. Now I'm going to look at my sig figs, okay, and my given only has 2 significant figures, and so my answer will be 52 liters. Okay, all right, so E, convert 25 yards, okay, per hour to inches per second. Okay, again, don't get overwhelmed. Let's do this together. So 25 yards per hour. Okay, and we want to end up with inches per second. So let's convert. Okay, and let's look at yards first. We want to get rid of yards. Okay, so there's yards, but we know we have 1 yard and 3 feet. Okay. All right. We're not happy with feet because we want inches. We know that 1 foot is equal to 12 inches. Okay. Our feet cancel out. And now we multiply. 25 times 3 times 12 is 900 inches per hour. But we don't want hour. We want seconds. So now we have to get rid of hours. So in order for us to get rid of this denominator, we have to put it in the numerator. So we don't know how many seconds are in an hour, but what we do know is that we have 60 minutes in an hour. So 1 hour is equal to 60 minutes. My hours cancel out. And I do know that 1 minute is equal to 60 seconds. So now my minutes are able to cancel out. And I know how to set it up because, again, I'm allowing for my unit to guide me. So now I end up with 900 inches over, and I have to multiply 60 times 60, 3,600 seconds, because inches and seconds cannot cancel each other out. So 900 divided by 3,600 gives me 0.25 inches. You can write it per second or leave it as a fraction. All right, so now 13 is asking us to give, and this one can vary, differentiate between quantitative and qualitative measurements. So give three examples of quantitative measurements. And again, remember, look at quant. When I asked you what quant reminded you of, you said quantity. And you were right. But whenever I ask you for a quantity of something, you're going to respond to me with a number. So you can either tell me, okay, so how much do you weigh? You can tell me, I weigh 40 kilograms. I can ask you, how tall are you? And you can tell me, I'm 1.5 meters tall. I can also ask you, how much water did you drink today? You can tell me you drank 4 liters of water. And notice how every single one of these measurements has a number associated with it. All right, the next type of measurement or observation or data is qualitative. And qualitative has nothing to do with numbers. And so I can ask you, what color is your shirt? So your shirt is red. I can ask you, how does that table feel? That table feels smooth. Okay. I can ask you, how does that floor feel today? You're going to say, this floor feels slippery. Okay. And notice how there's no numbers associated with these types of observations.